Very good evening to all of you guys. Welcome to BYJU'S Exam Prep once again. So guys, here with a new session which is based upon the structure analysis. So before this particular session guys, we have already completed the environmental engineering part 1 as well as we have completed the RCC. So this is the third subject guys which I will take, that is basically structure analysis, and hope all of you are able to understand all the concept which we have discussed in. Okay. So let's continue the session guys, and please share it also to other students so that everyone can know and they will also get benefit from this session. So guys, those who are new over here, let me tell you about myself also. My last 9 my subject is basically environment structure. So guys, as you know that this series is based upon IIT Kanpur PY. It is a no doubt important series, as well as you know that you are able to solve all these, that you will get idea what type of question they are generally try to plan in our upcoming gate. But at the same time guys, we have one new series for all of you guys, that is basically gate champion series. uh Gate champion series. Just a second, I think voice is just a second, just a second. Hello, hello, hello. Check. Hello. Hello, 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 hello. Hello, dear students. Are you able to listen me properly? Hello, dear students. I think now audio is clear. Audio is perfect from my side. Please let me know, guys, quickly. Hello, Santu. Hello, Preetham. All okay. So let's start it again, guys. So welcome to BYJU'S Exam Prep once again, guys. And today we will discuss the PYQs of IIT Kanpur for the structure analysis. So guys, as you know that we have already done basically two subjects, which is basically RCC as well as environmental engineering, and in which we have discussed a lot of question which was asked by the IIT. So guys, let me tell you one more thing. Today this is the last subject which I will take, but this is not the last session, because we are upcoming with a new series which is basically GATE Champion series, in which we have put it 500 important question from your technical subjects, right? And this is basically live GATE workbook. So some students are getting difficulty find out the good number of question and good quality of question like MSQ, MCQ and NAT type question. So if you want to join, guys, this particular live GATE workbooks, so you can join it on BYJU'S Exam Prep channel, and it will be starting from 25th of, right? So guys, this series is very important. Kindly join it, and definitely you will get benefited from this particular series. Okay. In this particular series, we will discuss the question part. At the same time, we will discuss the conceptual things also. So whatever concepts are required as per the question, we will discuss that point also, right? This particular series will be on YouTube, and the timing for this particular series you will get information of it right after some time. What will be the timing? I will tell you about it. So guys, there is one more point I need to explain over here. You can give the GATE scholarship test also if you want, so that you can get some scholarship on GATE preparation program. So on 20th of August, this particular scholarship test will be there, guys, at 8, which you can give easy, right? So let's start this particular session with the question number 1 and tell me the correct answer, guys. This particular problem was asked by the IIT Kanpur in GATE 2001, which is based upon static and kinematic indeterminacy. So tell me the answer, guys, quickly. Okay, tell me the answer quickly. This is the question. The frame is given to us and we need to find two values. One is static indeterminacy and second is kinematic indeterminacy. Now in case of kinematic indeterminacy, you need to assume the axial deformation is to be negligible. That means you have to consider the member are inextensible in nature. Simple. Okay, please tell me, guys, quickly which particular answer is correct for the question. Which particular answer is correct? Quickly tell me, guys. A, B, C, D. You can see here, guys, NS value is representing the static indeterminacy and NK value is representing the kinematic indeterminacy. Tell me, guys, quickly which particular answer is correct. At the same time, C. Very nice, Neeraj. C. Neeraj. Preetham, C. Shandar. Okay. So a lot of students are saying, sir, C is the correct answer. Very nice. Let's see, guys, how many of you are giving the correct answer. Let's solve this particular problem. So first, I wish to find out the static indeterminacy. You know that, guys, the value of ds is nothing as it is the summation of dse plus dsi, correct? So this is the fixed support. I need to consider 3 external support reaction at it. This is hinge 1, so I need to consider 2 reaction. Similarly, this is also hinge. We need to consider 2 reaction. So the total number of reaction is equal to how much? 3 plus 4, that is equal to 7. Can we write, guys, dse is equal to re minus 3? Re minus 3. So it is equal to how much? 7 minus 3, that is equal to 4. Now the second thing is we need to find out the DSI value also. But you know that guys, this structure is an open structure. So the value of DSI is equal to how much? It should be 0, right? So the value of DSI is 0. If DSI is 0, DSE is equal to 4, then what is the value of DS? What is the value of DS? Edit, get the answer as a 4. That means there are only two options which can be possible, either C or D. Because we know that guys, A is not the correct answer, B is not the correct answer. Clear? Okay. Now what about DK? Anyone? What about DK? What about DK? Can I write guys? DK is equal to PJ minus RE minus NR plus R dash. Now how many number of joints are present on the structure? 1, 2, 3, 4, 5, 6. So 3 into 6. Number of reaction 7. Then the number of axially rigid member, or you can say that number of inextensible member. 1, 2, 3, 4, 5. 5 member are there, and the number of reaction release on the structure is 0. Okay. So let's solve it. How much value you are getting guys? 3 into 6 minus 7 minus 5. So I think you are getting a value of 6. That means DK is equal to 6 and DS is equal to 4. That's why C is the correct answer. And Santu, you are wrong, but no issue. Sahu, Chetyu, Preetam, Neeraj, all of you are correct. Very nice. Okay. Okay. Next question guys, in front of you. Next question in front of you. Tell me the correct answer of it. Next question in front of you. The bending moment at the mid span location X in the beam with the overhang shown below is equal to how much? Again, this question was asked in GATE 2001, right? GATE 2001. Very easy question. But guys, while solving this particular problem, you need to find out the reaction also, right? A 0. Neeraj says are 0. Okay, what about other students? Tell me guys. Neeraj says sir 0. The bending moment at this particular point X is equal to 0 as per the Neeraj. Okay, let's solve this particular problem also. Listen guys, as you know that it is the basic property of the structure, we can take summation of moment at any point is equal to 0. That particular point can be present on anywhere on the structure, correct? Let us suppose this particular support is A. Let us suppose this support is A. And let us consider the reaction which is present is, okay sir. Now I wish to find what is the value of VA first. I wish to find what is the value of VA. So let us suppose guys, this is the point where I need to find the value of moment, summation of moment, right? So let us consider this point is B. So can I say that summation of moment at point B should be equal to 0? Can we say that? Yes. So let's solve it guys. So 20 into how much distance? 3. So can I say that it is basically anti-clockwise in direction? So I will write minus 20 into 3. Then plus this VA is trying to rotate this particular point B in the clockwise direction. So we need to write VA into 2. Okay. What about this 10? 10 into 1. It is trying to rotate as a anti-clockwise or clockwise? Tell me guys. Clockwise or anti-clockwise? This 10 into 1 is trying to rotate this particular point B in the clockwise direction or anti-clockwise in direction? Clockwise in direction, correct? So guys, you need to write what? Plus 10 into 1 and it should be equal to 0. So what is the value of VA which you are getting right now? Anyone who can tell me? 20 into 3 minus 10 into 1 and divided by 2. So what is the value of VA which we are getting right now? VA is equal to how much? 25 kilonewton. VA is equal to 25 kilonewton. Now I wish to find what is the value of bending moment at point X. It is very simple. So can I write here guys, the moment at X point is equal to 20 into 2, okay, which is in anti-clockwise direction. So we will write minus because it is trying to create hogging moment. So 20 into 2 plus 20 into, sorry, 25 into 1. 25 into 1. Kindly calculate this value. So we are getting a value of minus 15. That means minus 15 kilonewton meter as a hogging moment. So C is the correct answer for the problem. Crystal clear? Tell me guys, it is crystal clear to all of you? Crystal clear to all of you? How we can solve it? Okay, very nice. Let's move to the next question. Now this question is based upon the theory part, right? And I think all of you are able to give the answer correctly. So please put your answer guys, read the question first and try to understand what type of force will develop in the different type of member which is present in the structure. It is basically a truss. So tell me guys, which of the following statement is a false statement? You need to tell me which statement is a false statement. Which statement is a false statement? Tell me guys. False statement. We need to find the false statement. So as per the question, what is happening? Identify the false statement from the following pertaining to the effect due to the temperature rise delta T. So basically in member BD, the temperature is trying to increase. Okay. This is your member BD and in this member, the temperature is trying to increase. Now tell me guys, which of the following statement is wrong in this particular case? That is the question. Which particular statement is wrong in this particular case? So as per the first statement, there is no reaction developed at support A and D. I think this one is true or false. This one is true or false? It is true, yeah, it is true. It is not false. Definitely there is no support reaction will develop in this case, right? There is no support reaction which will be developed over here. Second thing, the bar BD is subjected to tensile force. Now listen guys, when this particular bar is trying to extend, tell me guys, when this particular bar is trying to extend due to the temperature, so tell me which type of force this particular member is trying to do. You can say that compression force, because due to the increase in temperature, member is trying to extend, but the member is trying to apply the compression force so that it can regain its original shape. Correct? So that's why can I say that guys, B is the correct answer, because this is a false statement. In actual condition, in BD member, the force should be compressive in nature, not the tensile one. Right? It should be compressive in nature. Yes, Preetham. Yes, Santu. Yes, you are correct. Right? B is the correct answer for the problem. In BD member, it should be compressive in nature, not the tensile in nature. Clear? Next question in front of you guys. You need to find out which particular figure is trying to show the correct deflection diagram. Tell me guys, the deflected shape of the structure. Which one is the correct deflected shape of the structure? It is very easy to understand. Preetham says a D. Very nice. D. Santosh, D. Very nice. So you can see guys, this support is a roller support right now. If you put any load, so this roller support is trying to move in the forward direction. So definitely if it is trying to move in forward direction, due to that reason, this member will also get shifted in the horizontal direction. So let me show you the figure so that you can understand guys how it moves actually. So you can see guys, this joint will try to move in the forward direction like this. Okay. But we know that this member and this member is trying to maintain the angle which is basically 90 degree, right? Because the joint is rigid in nature. That is the reason. Okay. The joint is rigid in nature. So let us suppose this point is also get shifted at this particular point, and we know that guys, due to the loading, this member is trying to bend little bit like this, and this member is almost straight in nature because this member is trying to rotate about this particular hinge. So this one is the deflected shape of the structure. That's why D is the correct answer for the problem. Clear? Okay. Next question guys, next question which was asked in GATE 2001 again, and you need to find out the false statement again. Which particular statement is false in this particular? Tell me guys. Kindly read it and let me know the answer. The first statement says, influence line for the stress resultant in the beam can be drawn by using Euler-Breslau principle. We know that guys, for any kind of stress function, you can draw the ILD by using Euler-Breslau principle, and Euler-Breslau principle will give us only the shape of ILD. So we can do it, right? So the statement A is correct. But what about statement B? Let's read it. The moment distribution method is a force method. Now tell me guys, the MDM method is a force method or displacement method? MDM method is a force method or displacement method? Guys, we need to solve 19 question. Okay, you need to respond quick as possible. Okay, we need to solve 19 question. Total 19 question is there from your GATE 2001, GATE 2015. Yes, it is a displacement method. That's why statement number B is a false statement. That's why this answer is a correct answer. Clear? This answer is a correct answer. Clear? Now the next question, which is based upon the moment distribution method guys, but without solving this question I can tell the answer also, right? And it is very simple to understand also. But before I will explain guys, please let me know the answer from your side also, right? Tell me which of the following answer is correct. You need to find out the correct set of the bending moment, which is MOA, then MOB, then MOC. You need to tell me the correct set of the bending moment which is developed. Santu D, very nice. What about other students? Tell me guys. What about other student? D, very nice. It is very simple problem guys. Why? Because we know that whenever we are having any kind of free end, the stiffness of that particular member will become how much? It should be 0. If stiffness is 0, then the distribution factor is equal to how much? It is also 0. So whatever moment which is coming at this particular joint get divided into the each of the member which is present at this particular joint as per their distribution factor. But tell me guys, if the distribution factor of OA member is itself 0, so what is the value of moment which is taken by the OB member? It should be 0, right? And there is only single option in which OB value is equal to 0. That is basically D. And that's why D is the correct answer. D is the correct answer. Clear? Crystal clear to all of you? But if you want to solve it guys, we can solve it also. It is very easy. We need to find out the stiffness. We need to find out the distribution factor also. Then we will get divide this particular moment by using MDM method, right? D is the correct answer. Next question, again asked in the GATE 2001. Please consider this particular point B and point D as a hinge, internal hinge, and this is basically your fixed support. Okay. Now let's read the question first, then we'll discuss. Identify from the following correct value of the bending moment MA. We need to find out the value of M in kilonewton meter at the fixed end in the statically determinate beam shown below, with the internal hinge at point B and at point D. These are the internal hinges. When we are trying to put a UDL whose intensity is 10 kilonewton per meter and it is placed on all the span, that means on the entire span the UDL is to be. Now what type of hint they are giving? Either you can solve this particular problem by drawing the ILD, or you can use the principle of virtual displacement. But it is better to solve this particular problem by using ILD. Okay, let's understand guys how we can do it. First of all, I need to draw the ILD of movement at A, right? You know that guys, if I put the reaction like this, which is basically MA, So I need to draw the ILD for this particular reaction MA. Okay, how we can do it? As per Mueller-Breslau law principle, what we need to do? We need to release that particular reaction. So if you want to release it, you need to change the support condition. So let us change it. Initially it was fixed, now it is hinge. Okay, and the other support condition will remain same. It is internal hinge. This is also internal hinge. Then we have a roller support. Then it is also roller. Okay. Now as per Mueller-Breslau principle, you need to give the unit rotation. If you are removing MA, you need to give the unit rotation. Okay. So that means I need to put theta is equal to 1. So whatever deflected shape of structure you are getting, that will be the ILD for MA. Okay. So can I say that, guys, this is your deflected shape of the structure? Kindly see it. Correct. Now what is the span which is given to us? The value of span, I think it is symmetry on both the side. So it is, oh, it is not symmetry. Wait a minute. Let me check it. I think it is symmetry. I think there is some dimensional mistake over here. It will not be 3. Just a second. Yes, it is 2 meter. It is not a 3 meter, right? It should be 2 meter. In actual question, it is 2 meter, not 3 meter, correct? Now kindly see this particular ILD, guys. This area is positive area and this is negative area, right? Now tell me, what is this span? It is 4 meter and this one is also 4 meter. 4 meter and 4 meter. Now, how you can find out the value of MA? You need to put UDL on the entire area of ILD, right? Then UDL intensity multiplied by area of ILD will be your value of MA. Clear? That will be the solution. So MA is equal to intensity of UDL is equal to how much? It is equal to 10 kilonewton per meter. Okay, sir. 10 kilonewton per meter. Multiply by 2 area. One is positive, second is negative. Now you know that, guys, both the area are same. Why? Let me explain. If this is theta is equal to 1 and this is 2 meter, if this is theta is equal to 1 and this distance is 2 meter, then tell me, guys, what is this value also? Anyone who can tell me what is this value? Can I say that this is also 2 and this one is also 2? This is also 2. Now you can see, guys, one area is positive, one area is negative, and both the areas same, but they are having opposite sign. That's why they will get cancelled and ultimately value of MA will become 0, right? But let me solve it also. So half into 2 into 4, this is the area of positive, minus half into 2 into 4. Then, guys, if you solve it, you will get 0 as the answer. The moment at A, when the UDL is present on the entire span, is equal to how much? It is equal to 0. That's why C is the correct answer for the problem. C is the correct answer for the problem. Crystal clear? Crystal clear to all of you? Very nice. Let's move to the next question. And again, it is a very simple. Okay, very simple question. Tell me the answer, guys. As per the problem, U1 and U2 are the strain energies which is stored in the prismatic bar due to axial tensile force P1 and P2 respectively. The strain energy stored in the same bar due to combined action P1 and P2 will be equal to 1. Now you need to tell me, guys, which particular relation is correct. Kindly consider U is greater than U1 plus U2. Tell me, guys, which particular answer is correct? As per Preetham, it is A. Okay, Preetham, we will check it out. Any other student who want to put the answer? Let us suppose, guys, this is our member in which the axial force is present. Santu D and Preetham also D. Okay. Let us suppose, guys, this is the P1 load which is acting on this particular member. So what is the strain energy which is stored in this member? Can I say that it should be P1 square L by 2AE? Okay. Similarly, let us suppose if we take another member another member in which the load is P2. This is P2. Then what is the value of strain energy which is stored? Can I say that it is P2 square L by 2E again? Okay. But let us consider, guys, if we are using the same member, and on the same member if I try to apply the load which is P1 plus P2, then the strain energy is different, right? And how much it is? The strain energy will be P1 plus P2 whole square into L divided by 2. Now tell me, guys, if you make it whole square, then this particular term is greater. So P1 square plus P2 square plus twice of P1 plus P2 bracket multiply by L and divided by 2A. Correct? Now kindly see this particular expression. You are able to understand the total strain energy is greater than U1 plus U2. Yes or no? This U value is always greater than U1 plus U2. Yes or no? That's why, guys, D is the correct answer for the problem. D is the correct answer for the problem. Clear? D is the correct answer. Santu, correct. Preetham, correct. D is the correct answer. Clear? Okay. So let's move to the next question. Now this problem is based upon the deflection of a truss joint, right? And no doubt in this particular question we need to do a little bit lengthy analysis to solve this particular problem. But there is no issue, guys. I will tell you some short step by which you can calculate this particular deflection. So how we can reduce the number of steps over here, right? So let's read the question once again. The right triangular truss is made up of members having equal cross-sectional area whose value is equal to 1550 mm, and the modulus of elasticity is given to us. We need to find out the deflection of joint Q in the horizontal direction, right? And the load is also mentioned, it is 135 kilonewton. This height of a member is 6 meter. This length is 4.5. Can we calculate this PQ also? Yes. Let's use the Pythagoras theorem. So 6 square plus 4.5 square and under root of it. So we are getting a value of 7.5 meter as the length of Q member. Okay. Now let's see, guys, how we can. I need to draw a table where I will write member, then whatever force which is coming due to the external loading, then K system of force, then L, then we will find it out what is P. I will explain this particular table once again, guys, why we are doing this. This is K system of length and this is the product of. Okay, so let's understand, guys, what is the value of delta QH. So it is nothing as it is summation of PKL upon A, right? And this particular summation is to be done for all the members. I is equal to 1 to I is equal to. Now what is P? P is nothing as that is the forces in the member due to the external loading. Okay. What is K? K is nothing as it is the force which is developed in each and every member due to the unit load which is placed at the joint Q in the horizontal direction, right, where you have to deflection. Okay. So guys, what are the member we have? Q, then PR, and then RQ. Okay. What is the length of each member? What is the length of each member? PQ is equal to how much? 7.5 meter. Then PR is equal to 4.5. Then RQ is equal to 6 meter. Okay, sir. Now guys, we need to find out the forces in each and every member due to the external loading. Okay, let's solve it. So what we will do, guys, we will try to find out the horizontal reaction in this particular case only. Okay, I will not find the vertical one. Why I am not finding the vertical reaction, I will tell you. No doubt we can solve it in a proper manner also, but guys, this is the objective question. Need to be fast, as quick as possible. You will get the answer. That will be much better. Now tell me, guys, at this particular support we are having a horizontal reaction, correct? So if 135 is trying to move in this direction, so can I say that my horizontal reaction should be like this, right? And that value is equal to how much? HR is equal to how much? It should be 135 kilonewton, correct? Okay. Now what we will do, we'll try to consider joint Q and we'll try to consider joint R to find out the forces in all the members. That's it, right? So let's take joint Q first. Okay, let's take joint Q first and try to draw the free body diagram of joint Q. So this is your horizontal action, which is 135 kilonewton. Then we have vertical reaction, the member, which is basically TQR and TPQ, or you can write here this way also, P, PQ and PQR. Okay, and this is nothing as our theta. You can find out the theta easily because we know all the dimension of the member. Okay, so can I write here, guys, summation fx is equal to 0. So it should be 135 minus PQ sine theta, and it should be 0, correct? So 135 minus PQ and sine theta. What is the value of sine theta? You need to check here, guys. If this is the value of theta, then this is the perpendicular and this is the base. Sorry, this is the base and this is the hypotenuse. So 4.5 divided by 7.5, and it should be equal to 0. So tell me, guys, what is the value of PQ which you are getting right now? PQ is equal to how much? Anyone? 225 kilonewton. 225 kilonewton as P. Clear? At the same time, I need to find out the QR also. I need to find out QR also. All of you are getting the same answer? PPQ. Okay. Next is summation Fy is equal to 0. If you take summation Fy is equal to 0, that means minus PQR minus PPQ cos theta, it should be 0. So we don't know the value of PQR, okay, no issue, but we know the value of PPQ. That is minus PP cos theta. Okay, what is this value? It is minus 225 multiplied by cos theta. Now what is the value of cos theta? Let's check it. Cos theta is nothing as base upon hypotenuse 6 by 7.5. How much you are getting? 225 multiplied by 6 divided by 7.5. It is 180, but it is negative in nature, minus 180 kilonewton. So this is the value of PQR which we are getting right now. PQR minus 180. Okay, sir. So let's write it down also. So PPQ is equal to how much? Plus 225 kilonewton. This value of PQR, it is equal to how much? 2R, that is minus 180 kilonewton. Now tell me, guys, what is the value of PR? If you consider joint R, so whatever horizontal reaction is there, guys, the same value of the force will develop in PR also, Okay, so let's analyze it also. So can I write here? Joint Very nice, Santu. Joint, but we will solve it so that everyone can understand. Joint R, joint R, joint R. So this is the support, and now you are able to understand why I am not finding the vertical reaction, because it is not required here. It is not required. Now you can see, guys, this value is what? 135 kilonewton. 135 kilonewton, and this value is 135, and this is PPR. Okay. Can we write summation fx is equal to 0? And if it is fx is equal to 0, minus PPR minus 135 should be equal to 0. So if you solve it, you will get PPR is equal to minus 135 kilonewton. It is minus 135 or plus 135? Tell me, guys. Minus 135 or plus 135? Tell me. Minus. Very nice. So let's write it down. It is minus 135 kilonewton. Minus 135 kilonewton. Now tell me, guys, if these are the value due to 135 kilonewton load at the, this is 135 kilonewton load which is present at this particular point. Due to 135, these are the values which we have, right? Now let us suppose if I replace this 135 by 1 unit of force, then what is the value of forces which develop in other member? So you need to divide all the value by 1. You will get the K system of force. Why? Because K system of force is nothing as we need to apply the unit load the joint where we need to adjust, right? And we need to remove all the external loading and try to find out the value of forces which is developed due to the unit in all the members. So guys, just we need to divide all the value by 135. You will get the K system of force easily. So don't change the sign, just kindly divide it by 135 directly. You are getting a value of 1.67. This one is minus 1. And this one is minus 1.3. Now kindly solve it. 225. This is 225 multiplied by 1.61 multiplied by 7.5. How much we are getting? 2818.125. Now see here, guys, this K system of force is dimensionless. The unit of this particular calculation will be kilonewton meter. Okay, 135 multiplied by 1 multiplied by 4.5. So we are getting a value of 607.5. What about this one? 1436.4. Now what you need to do, guys, you need to add all the value, then you will get summation of PKL easily. And I think all the value which we are getting is positive in nature as a final result. So how much you are getting? 4862.025 kilonewton meter, correct? Now you know that, guys, what is the value of delta QH? It is nothing as summation PKL upon A. So what is the value of PKL? It is 4862.025, then multiply by 10 raised to power 6. So that is converted into Newton mm. Okay, sir. Then we need to divide it by area. What is the area of member? It is 1550 mm square. Multiply by E. E is equal to how much? 2 into 10 raised to power 5 Newton per mm square. Now tell me, guys, if this is Newton per mm square, this is Newton per mm square, will get cancelled. This Newton is also get cancelled. Now what is the displacement which you are getting right now? Tell me. What is the value of displacement which you are getting right now? Quickly tell me, guys, how much it is. No doubt this problem is a little bit lengthy, but you need to understand how to solve it. So guys, we are getting a value of 15.68 mm as the answer, and this is the correct answer as per the problem. So D is the correct answer. D is the correct answer for the given question. Clear? It is crystal clear to all of you. Tell me guys, yes or no? D is the correct answer. 15.68. Perfect. So let's move to the next question, which is based upon ILD. ILD of the member. Oh, sorry. The ILD is already given to you guys. You need to tell me which particular member for which this ILD is given to us. Now, no doubt guys, we can solve this particular problem by the analysis also. But you need to remember certain fundamental so that you can solve such type of problem of ILD of Truss member directly in your examination. Without writing anything, you can solve it also. So let me tell you some of the trick guys so that you can use it. Okay. Let us suppose this is our member. Listen carefully, you will understand what I want to explain. Let us suppose guys, this is our truss, right? Now tell me, whatever top member you have, in that top member, which type of force will be there? It is compressive in nature or it is tensile in nature in general? Arey Baba, tell me, if you try to bend the beam like this, then the compression will occur at the top or tension will occur at the top? Tell me guys. Compression. So can I say that guys, for top member, it is always compressive. So whatever ILD you will get guys, for the top member it is always compressive in nature. Here, if we talk about bottom member, this one. So in the bottom member, tension will develop. So can I say that in the bottom member, the ILD should be tensile in nature. For bottom member, it should be tensile in nature. Tensile in nature. Here. Now if we talk about the inclined member. Now how your ILD look like for the inclined member? So for inclined member, please remember these tricks. You have to use it directly in the examination, right? So if you have inclined member, so in case of inclined member, then the nature of ILD is trying to change from compression to tension. It is initially compressive in nature, then it will become tensile in nature. Clear? But if we talk about vertical member, any of the vertical member, if we talk about vertical member, it is opposite to the inclined one. That means it is starting with the tensile, then we will have compressive in nature. So this is the fundamental which you have to remember for your examination. Now tell me guys, in this particular case, the nature of ILD is what? It is compressive to tensile. If it is compressive to tensile, then tell me guys, for which particular member this ILD is given to us? It is PS, it is PR, it is PQ, or it is QS? Tell me guys. Now tell me the answer. For which member this ILD is given to us? It should be PS, which is inclined one. Inclined one, because it is trying to change from compression to tension. That is the reason. Okay. So A is the correct answer. But let me tell you one more thing over here. If you want to actually analyze the ILD of any kind of truss member, then only we can find out the variation, which type of variation is occurring truss member due to the moving load condition. But guys, in the GATE examination, or let us suppose if you are giving the ESC prelims examination, you will not get sufficient time to draw the ILD, to solve the ILD for the truss member. That's why you need to remember this particular. Otherwise, what will happen guys? You will not able to solve such type of problem. But let me add one more point by which you can solve some other question. Let me explain. Let us suppose guys, if in general this is the member which they are trying to put in your truss, but let us suppose if the inclination is get changed, if the inclination is changed like this, if your inclined member is like this, then there is a little bit change in the ILD, and let me explain it. For top member, it will remain same, it is compressive in nature. For top member, again compressive. For bottom member, again it is tensile. There is no change in the top and the bottom member. But if we talk about inclined one, so for inclined member, For inclined member, now it is opposite to this one. Initially it was compressive to tensile. In this case it will become tensile to compressive. If the inclined member is like this, then it is tensile to compressive. And in this case, for vertical member, it is opposite to this one. That means now it is compressive to tensile. Here, please remember both the things so that you can use it in your exam. A is the correct answer. Next question is based upon MDM method, in which we need to solve it. This particular problem is based upon the continuous beam and find out the reaction as well as the movement at the middle support that we need. And no doubt guys, this question is very nice and we can solve it as quick as possible. So it is better to apply the MDM method. If you apply it, then guys, no doubt you are able to solve this particular problem. Okay, let's understand what is this question actually. So a two-span continuous beam having the equal span, each of the length L, is subjected to UDL W per unit length. Now the beam is having the constant flexure rigidity. We need to find out the reaction at the middle support. What is the value of reaction which is present at the middle support? That is the thing which we need to solve. Okay, so let me draw the figure first. So this is your continuous beam, and on this continuous beam the complete span is loaded with the UDL. It is loaded with the UDL whose intensity is already known to us, W kilonewton per meter. Here, this point is A, this point is B, this point is. I need to find the reaction which is developed at the middle support. That is the question. Okay, now listen guys, how we can solve it. Tell me guys, if I consider all the support which is present on the structure as a fixed, so can I find out what is the value of fixed end moment due to the external loading which is given to us? Correct? So can I say that guys, the bending moment or the fixed end moment which is coming at this particular end is equal to minus WL square by 12 due to this particular UDL. Similarly, at this particular end it will be WL square by 12, but it is positive in nature. For this particular end guys, due to this particular UDL value, it is again minus WL square by 12, and this one is plus WL square by 12. But this condition is satisfied when you are trying to consider all the ends are, that means you need to lock each and every support, then only you can write this particular moment. But tell me guys, in actual condition, this particular support is hinge and this support is also hinge. That means the bending moment value at the hinge support should be equal to 0. If it is equal to 0, then what I will do, I will try to apply a moment value whose max same is WL square by 12 but opposite in sign. So I will apply a moment at this particular end, value is WL square by 12, and at this end it should be minus WL square by 12. So tell me guys, if you apply any moment at this particular end, on the far end the carryover moment will go and it should be half in nature but same in sign. So what is the value of moment which is transfer on the far end? WL square by 24, and similarly on this end WL square by 24, but is negative. Now guys, you will get the final moment. Kindly add all the values, you will get the answer. This will be 0, this will be 0. If you add 1 by 12 and 1 by 24, how much it is? 1 by 12 plus 1 by 24, how much it is? It is 1 by 8. So we are getting a value of WL square by 8, and this value is minus WL square by 8. Very simple. So guys, this is one of the answer. Now let me show you that also. As per question number 12, the bending moment at the middle support is equal to how much? Tell me the answer guys. Are you able to see the bending moment value? It is WL square by 8. Tell me which one is the correct answer for the question number 12. Tell me guys quickly. What is the value of bending moment at the middle support? It is WL square by 8. B is the correct answer. But we know that we need to find out the reaction at the middle support also. So how we can solve it? What you have to do, guys, basically you need to divide this particular structure in two parts, because the structure is symmetry in nature as well as support condition is also symmetry. So let us consider this support is A. Let us suppose this support is B, but at this support I am considering only single reaction, that is RB1 or VB, and a UDL is to be placed on the entire, whose intensity is W kilonewton per meter, and the bending moment value at this particular end is 0, and the value of moment is WL square by 8, and it is positive. If it is positive, it is clockwise in nature. So you need to apply the moment like this. Tell me guys, similarly there is another half portion of the structure which is present, but at this particular condition you will have VB2 value as a reaction. Again UDL is there, and this is also hinge, and the moment is equal to how much? It is WL square by 8, but it is in anti-clockwise in direction because it is negative. Now first I will try to find VB. If you are able to find out the VB1, the value of VB2 is also same because symmetry is there. That is the reason. After getting VB1 and VB2, kindly add it. You will get the result. Clear? So let's solve it. Can I write here guys, summation moment at A is equal to 0. So minus of VB1 multiplied by L plus WL square by 8 plus WL square by 2, it should be equal to 0. Kindly solve it. So guys, we are getting a value of VB1 is equal to 5WL by, kindly check it out. All of you are getting the same answer. VB1 is equal to 5WL by 8. Now tell me what is the value of VB2? It will be same. VB1 and VB2 is same because the loading is symmetric, structure is symmetric, that is the reason. So ultimately total value of VB is nothing as, it is VB1 plus VB2. So if you add both the values, then how much you are getting? 5 by 4 into WL. Clear? Crystal clear? Tell me guys. So the correct answer for the problem number 11 is 5WL by 4. 5WL by 4. 5WL by 4. Clear? Okay. Let's move to the next question. Question number 13. Question number 13. Question number 13. In this particular problem, you need to find out K22. K22. Now tell me guys, all of you know that how to write down the stiffness matrix. The direction coordinate is given to us for any. So right now you can see here direction 1, direction 2 and direction 3. This particular matrix, stiffness matrix, is basically 3 cross 3 is the order. So let me write it down. The matrix is 3 cross 3, right? So what are the element over here? K11, K12, K13, K21, K3, K22, K2, then K32 and K. Now our task is to find out K22. That means we need to refer this particular column. Now guys, if you want to find out element K22, how you can do it? So as per the conceptual part, we need to give unit displacement. Listen carefully. Okay? We need to give unit displacement in direction 2. All three elements, 2 is common, right? We need to give unit displacement in direction 2, and log other coordinate direction, and find out force develop in direction 1, direction 2, direction. That is the correct. Okay, so let's do it. So guys, if we want to find out K22, I need to log the structure in direction 3 and direction 1. So if you want to lock it, that means I need to put a guided ruler, and please try to put the displacement in direction 2 only, which is basically delta is equal to 1. So the deflected shape of structure is to be like this. Now the question is, what is the value of force which is present in direction 2 over here, right? So tell me guys, if this is the value of delta and delta is equal to 1, so the direction of settlement or displacement is anti-clockwise, then the movement will be clockwise in nature. Okay. So how much it is? It is 6 EI delta by L square. Similarly, this one is also 6 EI delta by L square. Let us suppose this support is A, this support is B. So can I write here guys, summation moment at A should be equal to 0. So minus F into L plus 6 EI delta by L square plus 6 EI delta by L square again, and it is equal to 0. So F is equal to how much? It is 12 EI delta by L cube. Now tell me delta is equal to how much? 1. But this force is nothing as it is K22 element, because we know that K22 is trying to define, you need to give unit displacement in direction 2 and measure the force in direction 2, right? That's why the correct answer is how much? B is the correct answer. B is the correct answer for the problem. Crystal clear? Crystal clear? Very nice. Next question. It is very simple question guys. Question number 14 is a very simple question. Very simple question. Guys, the structure is symmetry. Loading is symmetry. Just you need to separate in two parts and try to find out the value of M. Very simple. Please tell me the answer. Please tell me the answer guys. Please tell me the answer. How much it is? What is the value of M which will be developed at the fixed end? Listen. Guys, in this particular case, can we break our structure in two parts? Because we can call it as two brother. There are two brother, right? Who has same nature, same strength. So you can see here guys, this is your hinge support, this is another hinge support, and there is one internal hinge which is present at this particular joint. Okay, and at this particular joint 20 kilonewton load is coming. So if I break this 20 into two part, one is 10 and second is also 10. So guys, you need to remove it. Just remove this particular thing. Okay, so can I consider this particular member is trying to take 10 kilonewton load only. So 10 into how much? 1. So this is the moment value which is coming at this particular joint. Kitna? 10 kilonewton meter. So tell me guys, on the far end, what is the carryover moment? It should be 5. Half of it. So the answer is 5. Very simple. The answer is 5. The answer is 5. Clear? Crystal clear? Crystal clear? Easy problem. Easy problem. Next question. Again, it is very easy question. Very easy question. You need to find out the strain energy which is stored in member XY. This is the member XY in which I need to find out how much strain energy is stored in this particular member. So guys, some student is trying to solve the problem by finding the value of external support. But guys, that approach will become very lengthy in this. So what you can do, you can cut a section like this. Okay, and try to consider the portion which is available on the top, so that you can find out the reaction in XY member. What is the value of reaction which is developed in XY member? So let's solve it. Now this is the 10 kilonewton load and this is the 5 kilonewton load which is coming on this particular joint. This is 5, this one is 10, and what is this? This is Fxy. Here. Now guys, can I write summation Fx is equal to 0? So 10 minus Fxy is equal to 0. So Fxy is equal to how much? How much force is there? 10 kilonewton. If it is 10 kilonewton force, then tell me how you can write the strain energy. It is Fxy square L upon 2. Okay, sir. What is the value of force? 10. So 10 square multiply by length. Length of xy member, it is 3. Divide by 2 into A. A is equal to 30. Please solve it. So we are getting a value of 5 kilonewton meter. That's why answer is 5 again. Answer is 5 again. Crystal clear? Very nice, very nice. Next question, which is based upon the support condition. You need to tell me for this particular structure or for this particular guided ruler, what will be the value of stiffness in direction X, direction Y and direction. How you can find it out? Let me explain. Tell me guys, what is basically force? How you can write force in general? F is equal to stiffness into displacement, K into X. And I think you have seen this particular formula in case of spring, right? So F is equal to K into X. Now tell me guys, if the value of displacement is 0, then what is the value of stiffness which is present in that direction? If the displacement is 0, can I say that the stiffness will become infinity? Correct? But let us suppose if displacement value is infinity, then the value of stiffness is equal to how much? Anything upon infinity is equal to how much? It should be 0, right? Now you need to use this particular concept to solve, and I think all of you are able to. Tell me guys, what are the number of reaction which is present? One is horizontal, which is Fx. Then we have my, m theta, we will write m theta, but the value of Fy is equal to 0. Clear? Now tell me guys, in the direction of X, what will be the value of displacement? It is 0. Tell me. In the direction of X, the value of displacement is equal to 0. Why the displacement value is 0? Because the reaction is present. If displacement is 0, then what is the value of stiffness in direction X? It should be infinity. So value of Kx should be infinity. Second, Fy. What is the value of Fy? It is 0. If Fy is 0, that means this particular support can move infinity in the vertical direction. That means X is equal to infinity, then stiffness is equal to what? 0. So can I say that Ky is equal to how much? Should be 0. Then if we talk about K theta, tell me guys, what is the value of rotation which can occur? 0. The member and the guided roller will not change its angle. That means it is equal to how much? 0. So if theta is equal to 0 or X is equal to 0, then what is the stiffness? It is infinity. So tell me guys, K theta is equal to what? Infinity. So infinity 0 infinity, infinity 0 infinity. This is the answer. Clear? Crystal clear guys, crystal clear. Okay. Now guys, there are two problems which I am giving you as a homework. Please try to solve it. Question number 19, which is based upon your moving load condition, and question number 18, which is based upon some spring reaction. Okay, please solve it by yourself, and this particular problem I am trying to solve in front, which is basically asked in the GATE 2015, last question of the session which we are discussing. Okay, the rest of the two questions you need to solve by yourself, and please let me know the correct answer also. Okay, so let's understand how we can solve this problem. So guys, in this particular case, I need to find out the distance of the point of contraflexure from the end A, and this is the end A. This is the end A. Now guys, what is point of contraflexure? Where the bending moment is trying to change its sign. Here. But in this particular case, we don't know the value of reaction at B. So let us consider this is basically how we can find it out. So first I try to resolve this particular structure in a smaller part. So can I say that guys, this reaction is VB, and due to this 10 kilonewton load, can I say that 10 kilonewton is coming in the downward direction? Okay, and due to this 10 guys, again will have a value of moment. I think this value is 1. Just a second. Okay, so this distance is equal to how much? This distance is equal to 0.25. 1 minus 0.75, it is 0.25. So what is the value of moment which is coming? What is the value of moment which is coming? 10 into 0.25. So you can say that it is 2.5 kilonewton meter, and this distance is 0.75 meter. Now tell me guys, the net displacement of joint D should be equal to 0. The net displacement of joint B should be equal to 0. So let's find out due to which particular reaction, or we can say that what are the value of displacement due to the reaction and the action part. So due to 10, it is minus 10, or you can say that PL cube by 3I. So 10 into 0.75 cube by 3EI. Due to this particular moment, again the value will be negative. How much it is? ML square by 2EI. So 2.5 L square divided by 2EI. Then due to VB, it is VB into L cube divided by 3EI. And the net displacement value is equal to how much? It should be 0. So tell me guys, what is the value of VB? Anyone? Please remove this EI directly and find out the value of VB. How much you are getting? Kindly solve it and let me know the answer also guys. What is the value of VB which you are getting after solving this? $15. Are you getting this particular value? 15 kilonewton. VB is equal to 15 kilonewton. Now tell me guys, what should be the distance from point A where the bending moment is trying to change its sign? That means we will consider that particular point as a point of bending moment is equal to 0 also, right? So let us suppose the distance of that particular point from C is equal to x, where the bending moment is changing its sign, that means point of contraflexure. So at point of contraflexure, the value of bending moment is also 0 in this case. So can I write here guys, it is minus 10 into x, then plus VB into this x minus 0.25. Then this is the distance between the reaction and the point which we have considered, x minus 0.25, and it should be equal to 0. So VB is equal to how much? 15. Okay, minus 10x minus 10x, then we have 15x minus 15 into 0.25. So this is value is equal to 3.75 and it should be 0. So 5x is equal to 3.75. So x is equal to this 0.75 from C point. So tell me guys, if this particular distance, which is basically 0.75 from the C point, is the location where the bending moment is trying to change its sign, or it is 0, so tell me what is the distance from point A? It is 0.25, and that is your answer. Clear? Crystal clear to all of you guys? Crystal clear to all of you? Tell me. It is crystal clear to all of you how to solve such type of problem. Okay. So this is all about for today, guys, and I am leaving two questions for you. You have to solve it by yourself and let me know the answer, guys. What will be the correct answer for the question number 18 and question number? Okay, try to solve it because we have already solved 17 questions. That is too much, and I think you are able to understand all the questions, right? So just try these two questions and let me know the answer, guys. And soon we will meet in the new series, which is basically the GATE Champion series, in which we will discuss the new type of question, which is not type question, SQ question, and uh, MC question also, right? So guys, this particular series will be starting from 25th, and definitely you will get the benefit from. Okay. So any doubt, any query, if you have, please let me know, guys. And I'm sharing one link over here, guys, in my chat box, so that you can join my Telegram, and ultimately you will get the information of this particular series also, when we are starting it, as well as what will be the timing. Okay, so kindly join this particular Telegram channel also, guys. Okay, I'm sharing the link. Any doubt, any query, if you have? Any doubt, any query, if you have? Okay, guys, so let's close the session and let's meet the next session, guys. Soon we will meet again, and you will get this particular PDF on my Telegram, and the link is already given in the chat box. Kindly follow it and you will get this particular, and the rest of the PDF is already shared. Please download it so that you will have the solution as well as the question. Bye guys, take care. Thank you so much for joining us. Let's meet in the next.